We're joined today by Dr. Simon Conway Morris, and thank you so much for being with me. It's a pleasure to visit with you today.
Thank you for coming to Cambridge.
And yeah, it's such a wonderful place, so full of history, and it's named after Adam Sedgwick, the museum where we are, and Adam Sedgwick proposed the Cambrian and Devonian periods in the geological timescale, I understand, and you did a lot of your work in the Cambrian, which is of great interest to anybody who cares about paleontology, I think. So tell us a little bit about what is the Cambrian and a little bit about your work in that.
Well, Cambrian, the name itself is effectively comes from a name for Wales, and many of the principal deposits in this country are exposed in the Principality of Wales, in fact where my brother presently lives, as it happens, and my family comes from there as well, so on that side, on my father's side. And the Cambrian is simply one of a series of intervals which subdivide the so-called stratigraphic column, and very crudely, with the appearance of fossils with skeletons, something which Darwin recognised, of course, in The Origin, one has an abundant record which provides immediate insights into evolution. Correspondingly, the so-called Pre-Cambrian, and that's really a colloquialism now, is the interval whereby one has, for the first approximation, only microbial life. So something rather dramatic seems to happen approximately 600 to 550 million years ago, starting before the Cambrian, but then leading to the so-called Cambrian explosion. So Adam Sedgwick, in his traverses of Wales, especially northern Wales, one of which was famously, he was accompanied by a young student from Cambridge called Charles Darwin, as it so happens. And of course, Darwin initially was a paleontologist for all intents and purposes, and only later became a naturalist. So in any case, the Cambrian is the stratigraphic interval which more or less defines the interval whereby fossils become abundant and readily identifiable.
Now, one objection that some people who have issues with evolution bring up is the time frame for the Cambrian, and they look at it and the objection goes, well, it happened too fast. We see the sudden appearance of all of these different life forms, and it doesn't look like we have a gradual lead up to this. How do you respond to that critique, and do you think it's valid?
No, I don't think it's valid in any useful sense for a number of reasons. To begin with, one should be careful to use terms like sudden in geology with respect to maybe an enormous volcanic eruption or the impact of an asteroid or something like that. With respect to what happened in the Cambrian and immediately beforehand, the time interval where we have reasonably good evidence for the first animals and then the beginning of the Cambrian itself is not really an explosion in as much as the interval might be as long as 100 million years. Okay? That involves precursors to the Cambrian, and this is an interval which is known as the Ediacaran. This too has an abundance of fossils which rather paradoxically almost entirely lack skeletons, but nevertheless are abundantly preserved, and there's a lot of discussion as to why that may have happened. But in brief, although the relationship between those fossils we see in the Ediacaran times and those which we see in the Cambrian are not that well understood, it's pretty clear, first of all, that these Ediacaran fossils are animals, and it's also pretty clear that they are the precursors of the Cambrian faunas, and thereby to describe any of this as sudden is an exaggeration. But perhaps as importantly, when you're looking at evolution, one has to remind oneself that it is, for all intents and purposes, opportunistic. And so if there is a change in the environment, and there's some arguments to suggest that possibly there were significant changes in ocean chemistry at about that time, if these facilitate the rapid evolution, relatively speaking, of animals, then that's what you're going to see. Yes. I wouldn't say it's as simple as that, but that's more or less in a kernel what seems to be happening.
Sure. So this 100 million years or so is it's relatively fast for geological time scale, but it's still not nothing, right? 100 million years is quite a long time.
Well, 100 million years would be more than from the time of the dinosaurs and when the more advanced mammals began to appear, and ourselves.
Right, yeah, that puts it in perspective.
That puts it in perspective.
Yes.
In contrast, the Earth formed approximately 4.5 billion years ago, It may have become habitable quite quickly, but there's some discussion about that. And there is convincing evidence of fossils from about 3.5 billion years ago, and pretty good indirect evidence that life was on the planet by 4 billion years, but all these are open to discussion. However, the more advanced forms of life, which are going to become, if you like, multicellular, things which would include the plants and the fungi and ourselves, may not have begun to evolve till perhaps 1.5 billion years ago. It's not entirely clear. So until we get to that stage of evolution, which involves the so-called eukaryotic cell, then one's going to be in effectively a microbial world, if you like, a bacterial world, which is also very sophisticated and very complex, but by and large does not produce large, obvious organisms.
Yeah, and this is on the timescale of billions of years leading up to the Cambrian. So there's a lot of things going on in the background to set the stage for this expansion into the new environment once the conditions are right in the Cambrian.
Yep. And you've got to remind yourselves also that to some extent fossilization itself is a somewhat of a chancy process. And especially if you're dealing with animals without their skeletons, which of course we have very interesting evidence for in the Cambrian itself, especially the Burgess Shale and Chengjiang. And corresponding, as I mentioned a moment ago, the Ediacaran material is also effectively soft-bodied. And I believe there's a recent paper, which I've not pursued properly, which suggests that some of the more complex forms may extend back to maybe even 1 billion years. Yeah. So like any other sort of science, one's got to remind oneself we're dealing always with provisional interpretation.
Yes, and the amount that we seem to find prior to the Cambrian keeps growing, and we keep seeing more complexity arising in that millions and hundreds of millions of years leading up to the Cambrian as well, right?
No, I think that's true. And there's an additional thing, is that sometimes we can be sort of over-impressed with morphology and what appears to be complex anatomy. And indeed, they are remarkable in as much as we are impressed by the embryology, for example, and how these complex forms develop in a very short period of time. But on the other hand, if one takes one of my favorite examples, and maybe yours as well, the nervous system, in point of fact, a good part of the components for which you need a nervous system actually evolve in microbial organisms. In other words, things which are essential for the operation of the synapses, for example, involve proteins and similar things, vesicle formation and the like, which are actually far, far predating the nervous system itself. So in other words, a good part of, if you like, the heavy lifting to provide what appears to be a very complex structure, the nervous system, actually is, if you like, already waiting to be recruited for this new function. And that's something we see throughout evolution.
Yeah, so if you're interested in nervous systems and sensory biology, like I am, then it seems like maybe all the really interesting evolutionary steps happened a long time ago, right? Before the Cambrian. At that point, you have nervous systems and you have eyes and things already that have developed. And this kind of leads into an interesting question about how some of these systems arise to tackle different problems in the environment. And one of the phenomena that you've worked on in this area is convergence. And tell us a little bit about convergent evolution.
Do we have 2 days? Convergent evolution is perfectly familiar to all biologists, although in passing I might note that Darwin makes very little play on it, and I suspect there was a particular reason for that, which we might come back to. But he wouldn't have been surprised by the facts of convergent evolution. But briefly, they are the observation that from different starting points in the tree of life, which admittedly we believe only has a single origin, but more or less independently, almost identical solutions, which might include the eye, for instance, have evolved for all intents and purposes independently. And the reason this interests me is twofold. One is almost anecdotal, and that is that when you read the literature on convergence, almost always the adjectives which are used are ones of surprise. Quite often words like uncanny or astonishing are used. And as a biologist, this slightly puzzles me, because you think, heaven's sake, this is natural selection operation. These are adaptations. But in a way, I think that is revealing something interesting about the way biologists look generally at the world. And that is, to the first approximation, they would suggest, I think, for the most part, that there's almost an open and unended sense of all things which might be possible. In other words, there's no predictability to evolution. It could go this way, it could go that way. Whereas convergence suggests to the contrary, not only are there recurrent solutions, like the evolution of the eyes, for example, but more particularly, although in principle there's an almost infinite number of possible alternatives, in reality, although we can't actually prove that, but in reality they are simply not viable. So the nodes of occupation in this otherwise, if you can imagine it, a sort of gigantic hyperspace of all possibilities, is absolutely infinitesimally small. The locations of comfort are very few and far between, which might explain why we see convergence being so uniform, so recurrent, so common. And in my view, not really noteworthy at all. What else did we ever expect?
So this might include things like physical constraints based on water or availability of chemicals in the environment, or the wavelength of light and photons that can be absorbed by sensory structures, things like that, that constrain the number of actual possibilities that can be derived in an evolved system to deal with this in the environment.
Yes, that's absolutely correct. I mean, one can imagine if in the end you want an eye, then it's got to deal with photons and it's got to deal with some receptor system. And again, we can tell a whole set of stories about the proteins which are involved there. But correspondingly, even within the organisms themselves, if you look at examples of, if you like, symbiosis, where you have different groups of organisms living together in one way or another, then one often sees again and again the same sort of solution being adopted, even though the organisms which are getting into deep association with each other are not closely related at all. So there's all sorts of examples of molecular convergence amongst enzymes, for example, which in a way reflects, of course, the nature of the so-called active site and the sort of chemistry it's dealing with. But corresponding, one also sees striking examples of convergence in genomes. And, for example, amongst many of the parasitic plants, for example, one sees a very dramatic reduction in the size of the genome. And this is important, I think, in a sort of way, because although, again, biologists emphasize the ever-growing complexity of systems, actually it turns out that what at first sight looks like a simplification, although it's nothing of the sort, but one which looks as if it's actually throwing away stuff. Again, it's not only convergent, but these convergences occur for exactly the same sort of adaptive reason which we see in any other context which looks to evolution. Sure.
Sure. So selective pressures, unless you have things like genetic drift in cases where maybe there's not a strong selective pressure for this time, and then things are kind of, moving along based on just random mutations in the background. But the constraints are what give directionality to the selective process that really forms these amazing adaptations that we see. I understand you're also interested in human exceptional uniqueness compared to the rest of the animal kingdom. Is that something that you'd like to visit about? Would you like to talk about it at all?
Oh dear, here comes a small confession. He looks at the camera like that and nods his head quite. Yes, as with the Burgess Shale, where I initially thought that the ideas of Stephen Jay Gould of more almost unrestricted possibilities was correct, I changed my mind.
Okay.
On the basis of convergence. Corresponding with human exceptionalism, at first sight, when you look at the convergences you see in terms of what we'd associate with advanced intelligence, which is a whole sum of things, which includes not only larger brains and more complex nervous systems, but also things like warm-bloodedness and homeostasis, which allows you to maintain a steady body temperature, various sorts of communication, including vocalization, such as you might see in birdsong. And the suggestion would be that this is a direct analogy with language, which we would otherwise associate as something uniquely human. This, if you like, this sort of wish list of things you need, is something which has clearly evolved many times independently. So we look at the birds, especially the crows and the parrots. We look at the cetaceans, the dolphins and the other whales. We look at the primates, both in the New World and the Old World. And again, we see striking examples of convergence, which suggest that the sort of things which will come to define a human are things which are very much on the evolutionary cards. And an implication of that, of course, would be that actually something like a human in terms of evolutionary process is, if not an inevitability, is something of great likelihood. And that, if it applies on this planet, ought to apply across the galaxy and beyond, and we might get on to discussion there. However, in the last few years, as I've been reading around, I've been more and more struck by the fact that though clearly we are derived from something fairly similar to a chimpanzee, probably in Africa. Notice I use the word probably. The evidence points that way at the moment, but it may change. Probably about 7 million years ago. This is looking pretty secure, but you know, one always keeps one's mind open. Despite that, in the way that Darwin identified, especially in his book on the descent of man, and also to some extent, I think, in the expression of emotions, the idea is that the difference between ourselves and our nearest neighbours, gorillas, chimpanzees, and for that matter, dolphins and birds, are simply ones of degree. They're not ones of kind. So there's a gradual process whereby we become, if you like, more and more fully human. And I think from an evolutionary perspective, that's absolutely correct. However, when we then go and look more closely at the sort of evidence which suggests that although all these things apply to animals and humans, there are a whole set of things in humans which we simply don't see in the animals. And you might say, well, that's simply because we've got a bigger brain, or there was a change in our genetics, and they may well be the correct explanations. But the more I look at this, the more I'm struck by the fact that we really are different. And the reason I think we're really different is, in a nutshell, because we are able to access effectively abstract worlds. And the most obvious example is in mathematics. And it's pretty clear that you might be able to train a chimpanzee or a parrot or something like that to engage in a facsimile of mathematical reasoning. But in point of fact, there's absolutely no reason to think that they themselves have the abstract capacity of understanding that 2 and 2 are 4 rather than anything else. And I could give a whole set of anecdotes in this particular area. Maybe 2 will suffice. One seems to be entirely trivial, but actually it tells me everything. And that is, and it's a paper I came across fairly recently, but many animals are social, dolphins, chimpanzees, and so forth. And indeed, if they're separated for sometimes quite a short period of time, when they reaggregate, they greet each other, understandably. They're delighted to see each other, by and large, not always. However, if you then see the converse of that, in other words, when the animals go away, no animal ever says farewell. No animal ever says goodbye. And I think the reason for this is effectively that no animal has any sense of a future. They live in a constant present. And of course they have memories of the past, but again there's a lot of discussion as to exactly how precise those memories are in the way that we can talk about yesterday, when we might have missed an appointment, as against several Mondays ago, when in fact we missed an appointment ourselves, and so on and so forth. And that to me seems somehow that animals lack this capacity to think of counterfactuals. Because we know that the future, to some extent, is determined, but also is open to endless possibilities. And that's partly what makes us human. Now, a second example, if I don't go on too long about this, is to do with the crows. And in this particular case, they are useful as an example of convergent evolution, because, of course, although they are vertebrates, they are derived from a group of dinosaurs, and they're not that closely related to the mammals. We have a common ancestor back, probably in the Permian, thereabouts, maybe 250 million years ago. But thereafter, the similarities between us in such things as cognitive activity are convergent. Now, the crows are particularly famous for their cognitive abilities, and amongst the things you can do with them is to train them, and thereby hangs another set of stories. You always have to train animals. They very seldom do it on their own initiative. And this goes back to a famous Greek story in Aesop's fables about the thirsty crow. So there's a pitcher of water with the water inaccessible, but a crow, which has a propensity, by the way, of carrying stones around, drops stones into the pitcher, thereby raising the level of the water so that the crow can assuage its thirst. So it's a nice story, a nice myth. And you can do exactly the same thing in a laboratory. You can train the crows to drop pieces of rubble into a test tube full of water, which also contains some food. And pretty quickly, they seem to understand what to do. But then you expand the experiments whereby you don't have a single tube with water and rocks nearby and food floating around as a bait. You actually connect the tubes in a hidden way underneath the platform on which the bird is strutting around. And some of these tubes are joined by U-tube, but other ones are disconnected. And it's immediately obvious that in point of fact, the crow is simply incapable of working cause and effect. It does not involve anything which we would regard as rational inquiry. What it does learn, and learns quite quickly, by trial and error, is how to do it. But the idea that it actually has a physical understanding of the displacement of water seems to be beyond it. And this too, again, I think in a way analogous to the fact that animals never say farewell, is that they have, if you like, this sort of barrier which we've gone beyond. And I think this is also reflected, and there's probably not time to go into that as well, with our language, and as I mentioned briefly about mathematics. So what's going on here? And I think in the end, you have to ask, well, what sort of world do we actually live in? If it's wholly material, then you would expect sooner or later something like a crow will become something like a human. If, however, it has immaterialities to it, things, as we say in the Creed, visible and invisible, then, of course, we might be open to these possibilities, which are not open, at least for the time being, to any other animal.
It's fascinating. And I think it's really interesting, this paradox that you articulated between how similar we are to our nearest primate relatives. It's really amazing when you start to notice how similar humans and other apes are, and yet how incredibly different. And you can hold these two, this paradox, simultaneously in your head, that we're relatives, we are cousins with these animals, and yet we're so radically different from them.
Sure.
And I love G.K. Chesterton, who it reflects on how if you look at the similarities between the human hand and the gorilla hand, the amazing thing isn't really how similar they are, it's how little the gorilla does with his hands compared to what humans do with our hands.
Sure, yeah. No, that's true. I mean, with respect to tool making, again, that's something which is pretty clearly defined, but a number of animals use tools, chimpanzees famously with their probes for termites and ants and the like. But to the first approximation, no animal ever uses one tool to make another tool. And if you can't do that, then you can't have anything which we would call a cumulative technology. So you're never going to be in the position effectively to make a machine, for better or worse, as we might observe, because we know that, as of course from human perspective, machines make us human, but they're also sometimes things which are extremely dangerous.
Yeah.
So it's a two-edged sword here. But with respect to the human-animal division, there are several questions begged by that, and one, of course, is that given we have good evidence from the fossil record of a whole series of homonym species going back to the Australopithecines or a bit before that, then at what point did we become human, so to speak? And that, too, I think is a very tantalizing question, and I don't have a simple answer to that.
Yes, very good. So maybe for the last question then, I know you are a Christian, and many people who will watch this are also Christians who are perhaps skeptical of evolution, or maybe somehow feel like evolution presents an obstacle or an incompatibility with Christian faith. In your personal experience, what would you like to say to somebody who might have sort of these this conflict inside of their head? How can what can you offer? Yeah.
No, I'm not sure I can offer very much, in as much as briefly mentioned, as a scientist, one knows that all that you're working on is provisional. It's a matter of hypotheses, and you always have to keep your mind open. That is not for a moment to suggest that evolution is not a fact, in as much as a historical narrative of the transformation of one species into other, and I can't see any reason to think that idea will be overthrown at all. It is, I would invite some of your listeners to try and step back a little bit from that, and indeed to read as much G.K. Chesterton as you could, along with other people, and to ask yourself, well, what sort of world is it we actually find ourselves in? How is it we find ourselves in this way, being able to understand the world at a much deeper level than seems to be in any way compatible with what we see in any other sort of animal? It's a rather grim thing, but for example, it's very clear that animals have encounters not infrequently with death, and especially if you look at the behavior of the monkeys and the chimpanzees. But it's pretty clear that although, for instance, in certain cases, a dead infant will be dragged sometimes for weeks around by its mother, and there's no doubt that there is some emotional involvement in all this. I'm not denying any of that, no more than I would deny that animals in their own way are conscious and have their own levels of intelligence, and they do exactly what they need to do for just the reason they need to exist. You know, I'm not demeaning them in any sort of sense. But it's pretty clear that they themselves have no sense of any beyond. And as has been pointed out by various authors, in the case especially of the great apes, they clearly, and it also applies to the elephants, they clearly realise that something has gone very badly wrong with their companion who is dying. But one has no sense at all that they could be persuaded that, in fact, that might not be the end of the story. Now, of course, many people in the West do think that's the end of the story, and, you know, at the end, at death, that you're out, that's it, nothing, you know, all a blank. Christians, of course, insist otherwise, and they have some reason to believe that they may have a point, so to speak. So rather than trying to look at the thing as a series of oppositions and saying, you better not believe in this because it might conflict with your beliefs in this sort of area, and it's not simply an argument for so-called concordism of trying to find, for instance, that the Genesis is somehow a proto-scientific document. In my opinion, it's nothing of the sort. One's really got to stand back and say, well, how is it that we can actually understand the world at all? How is it that we are rational? How is it that we see beauty in the world unequivocally? How is it that we are insistent in almost all cultures to build temples and places of worship? Why do we have a sense of the transcendent? Why do we have a sense of the numinous? Are these simply sort of anthropological bear traps, which are just fictions to make us comfortable knowing that we are mortal? Or you can step back from that and say in exactly the reverse way. These things are as real as anything else. And the very fact that we have to evolve to get to this position doesn't in any way prejudice our understanding of the new transcendences to which we've been invited. So it's really taking the story on and not, in my own view, getting over concerned about nitty-gritty of you know, one's ancestries amongst the primates. The evidence for that seems to be unequivocal, but I don't think that chimpanzees have religion of any sort at all, and we do. Why?
Yes, well, I think this has been a really fun conversation talking about questions no less exciting than the history of life on the planet and the meaning and even beyond, right? The great questions in life. So thank you so much for your time and for visiting with me today. It's been a real pleasure to talk with you.
Thank you also. Many thanks. Thank you. Thanks a lot.
That was wonderful. That was so much fun. Yeah.
Nice and simple.
Yeah, I'd love to continue it over a pint. Yeah.